Question 9.35. A vinyl record plays at 33.3 revolution per minute. Assume it takes 5 seconds for it to reach this full speed starting from rest. Question is asking us to find what is its angular acceleration during the 5 seconds and how many revolution does the record makes before reaching its final angular speed. Now the vinyl record starts from rest. So we can take its initial angular velocity omega I to be equal to 0 radian per second. And it takes 5 seconds to reach the maximum speed. So my time t will be 5 seconds. At the maximum speed, it plays at 33.3 revolution per minute. Now revolution per minute is the unit of frequency. So this is the frequency of the record at the highest speed. So I can write frequency f equals 33.3 RPM. We can convert the revolution per minute to revolution per second by dividing this term with 60 because every minute has 60 seconds. And after doing that, we get frequency as 0.56 revolution per second. If we have the frequency, we can use the relationship between frequency and angular velocity to find omega final. Omega final we can write as 2 pi times the frequency. So it will be 2 pi times 0.56. That gives me 3.49 radian per second. So these are the values given to us in the question. In the first part of the question, we need to find what is the angular acceleration. Angular acceleration alpha is given as change in angular velocity over the time. Change in angular velocity we can write as final angular velocity minus the initial angular velocity over time t. Final angular velocity we calculated as 3.49. Initial, since it started at rest, it is 0, divided by the time, which is 5 seconds. And when you solve this, you get the angular acceleration as 0.698 radian per second squared. This is the value of alpha. After you calculate alpha, part B of the question is asking me how many revolution does the record makes before reaching its final angular speed. Now before we find the number of revolution, I need to find what is the angular displacement delta theta. Once I got theta, I can use that to find my number of revolution n. So if we have initial velocity, the final velocity, and the time t, we can calculate theta by using the third equation of motion. The third equation of motion was to find the displacement x final minus x initial, which was equal to VIT plus half AT squared. When I write the same equation using angular quantities, I write theta final minus theta initial, which is my delta theta, equals omega I t plus half alpha t squared. So my delta theta becomes equal to omega initial is 0. So this whole quantity when I multiply with 0 becomes 0 plus half. Alpha is 0.698 and the time t given to us is 5 seconds squared. And when we solve this, we get the angular displacement delta theta to be equal to 8.718 radian, which we can round off to 8.72 radian. So this is the total angular displacement of the vinyl record. Now, in circular motion, when we make one complete revolution, the angle theta that we cover is equal to 2 pi. So we cover an angular distance of 2 pi when we make one complete revolution. So how many revolution do we make if we covered a distance of 8.72 radian? I can find the number of revolution made by dividing delta theta with 2 pi. Because one revolution gives you an angular displacement of 2 pi radian, so 8.72 radian will give you how many revolution? So let's find that. 8.72 divided by 2 pi, that gives me 1.38 revolution. So before coming to rest from its full speed, the record makes a revolution of 1.38. That is, it rotates 1.38 times before coming to rest.